A few months ago, astronomers detected a bona fide spacetime speedster in outer space, and in doing so, they gave experts a new nagging mystery to solve. Christened with the scientific name CWISE J1249+3621, we are dealing here with a confusingly small speeding star that races through the Milky Way at a breakneck speed of 1.6 million kilometers per hour. Unfortunately, we have no idea where this mysterious object comes from, what gives it its extraordinary speed boost, and what exactly it is. The cosmic world is always in motion, and our Sun is no exception. After all, our mother star covers around 940 million kilometers every year, traveling through space at a speed of 107,000 kilometers per hour, or 30 times the speed of a bullet. And although these figures may seem extremely impressive at first glance, in an astronomical context, the solar travel speed is rather leisurely. This, incidentally, also applies to almost all other stars that revolve around the center of the Milky Way. Yet, there are celestial bodies out there that break this common pattern and live up to their official designation. At speeds of 300 to 1,000 kilometers per second, the so-called hyperfast runners are actually fast enough to escape the gravitational pull of our home galaxy and break out of it. Experts have already tracked down hundreds of these stellar speed demons, which mainly come in the form of blue giants, binary stars, or supernova fragments. In addition, around 30% of the fast-moving stars are suspected of having an extragalactic origin. But what actually causes a celestial body to reach such an impressive speed? Well, according to the prevailing theory, the speed of most hyperfast stars is due to their turbulent past, more precisely, the cosmic catastrophes that they narrowly escaped. According to this theory, the stars were either rejected from their original binary system or narrowly missed a black hole. At least, that's the theory. However, a few months ago, astronomers identified a hyperfast runner that appears puzzling in many ways. Strictly speaking, the participants had not been looking for an exceptionally fast star. The citizen science project Backyard Worlds, Planet 9, which is carried out by volunteers, is actually dedicated to the goal of finding the ominous ninth planet and nearby brown dwarfs. As part of this, participants sift through special infrared images from the WISE Space Telescope, which scanned the sky from January 2010 and burned up in the Earth's atmosphere in November last year. While confirmation of the ninth member of our planetary system is still awaited, 3 amateur astronomers recently noticed a faint object that changed its position at an astonishing rate. In view of the extraordinary speed, co-discoverer Martin Katnick from Nuremberg initially assumed that the celestial body should have been documented long ago, but that was simply not the case. And so, a team led by Adam Bergesser from the University of California, San Diego, set about examining this strangely fast object for the first time with the help of the Keck 2 telescope in Hawaii. After the discovery became known, one examination with a high-resolution spectroscope later, it was clear that the stellar speedster was racing through the Milky Way at a speed of around 524 kilometers per second. This corresponds to a speed of about 1.6 million kilometers per hour, and for the astronomers, it was clear that the object named CWISE J1249+3621 could be fast enough to escape from our home galaxy. Aside from its speed, the celestial body also attracted attention due to its close proximity to the solar system. At just 400 light-years away, the star is actually the closest known hyperfast runner to Earth. Regarding the other stellar outliers in our cosmic neighborhood, experts stated that less than 0.002% of stars within 650 light-years of the Sun exhibit comparable tangential, or in other words, orbital velocities. However, the trajectory of the racer also runs transversely to that of most other stars. This means that it is currently heading for the center of our galaxy, will pass it at a distance of around 3,000 light-years, and will ultimately fly out of the Milky Way. Whether the star will ultimately be able to free itself from the gravitational bonds of our home galaxy has not yet been conclusively determined. While a good 15% of forecasts indicate a final farewell from the Milky Way, the rest point to an eccentric far-reaching orbit lasting 3 billion years. But the star itself appears even more surprising. Spectrographic studies revealed that it weighs only about 0.083 solar masses, making it unusually small. The majority of the previously known hyperfast runners have between 3 and 8 solar masses. In detail, the newly discovered object is actually just above the mass limit that allows a star to ignite and sustain hydrogen fusion. In light of this, experts estimate that the modest runner could either embody a faint subdwarf or a brown dwarf. The latter occupy a special position between stars and planets and are also known as failed stars. But in addition to its unresolved identity, scientists are also puzzled by the unusual composition of the compact hyper-runner. Analyses showed that it is very metal-poor and contains only a few heavier elements than hydrogen and helium. This special composition suggests that we are dealing with a very old celestial body, possibly even a member of the very first generation of stars in the Milky Way. But what, and this is perhaps the crucial question, has turned this little Methuselah dwarf into a hyperfast runner at all? Well, researchers have not yet found a definite answer to this question. However, at least the trajectory and properties have allowed them to play through a few conceivable scenarios. The first is based on the assumption that the star once formed a binary system with a white dwarf. But then, its stellar partner bid farewell to the cosmic stage in an explosive supernova. The later hyperfast runner raced away with its original speed and the additional speed boost from the explosion. Expert calculation showed that such an event seems quite conceivable. But the same applies to the second scenario discussed by the researchers. In short, the fast racer became a victim of a cosmic bowling alley. In more detail, it originally belonged to a globular cluster, in the densely populated centers of which stars and black holes are very close together and occasionally get in each other's way. As a result, objects can also bowl each other out of their orbits. If a star gets too close to a pair of black holes, it can even be hurled completely out of the globular cluster. The unusual trajectory of the hyperfast runner could be explained in this way. However, even if this assumption is correct, we have no idea which globular cluster the object involuntarily left. This is for the simple reason that no known globular cluster lies on the reconstructed flight path of the racer. Equally unresolved is the question of whether the star may have once come into close contact with Sagittarius A*, the central black hole of the Milky Way, and was consequently thrown off its original orbit. As we can see, the true background of the speeding dwarf is still overshadowed by many big question marks. To find out what story it has really lived through, further physical and atmospheric analyses are essential. After all, each of the discussed scenarios should have left typical elemental traces in the gas envelope of the star. The discovery of such chemical fingerprints would be a major step in unraveling the secrets of the stellar speedster. However, only time will tell to what extent astronomers will succeed in this endeavor. But if we turn our gaze to the past, we see that an even faster star has been detected, one that makes the one just discussed look like a snail. The fastest star in the Milky Way, discovered in 2020, is S4711. It is orbiting the Milky Way central black hole at an almost unbelievable speed of 24,000 kilometers per second, up to 8% of the speed of light. This incredible star takes just 7.6 years to complete a full orbit around the black hole. Detected in observation data from the Very Large Telescope in Chile, it only reaches its maximum speed near the black hole. Away from it, its average orbital speed is only 0.5% of the speed of light. Beyond that, S4711 could belong to a theoretical class of stars called squeezers, which heat up as they approach a black hole and cool down as they move away. The analysis of S4711 showed that it has a peak temperature of around 10,000 Kelvin, almost twice as hot as the Sun's surface. The bottom line? The Milky Way is home to some truly mind-blowing speedsters, and our understanding of them is still evolving.